Okay, we're going to start talking about inheritance and polymorphism. There's four key things we're going to cover. Number one, how references for subclasses work. Number two, how we can use subclasses in arrays of the superclass type. Number three, visibility levels. Number four, abstract classes, which we've seen before, but we're going to cover again. Okay, so first thing. This, I'm going to get rid of this stuff because I don't need it. If I have somewhere in memory a new B object that I've just created. So I have two classes, A and B. B is a subclass of A, and they both have an identify method. For A, it prints out the sentence, I am an A. For B, it prints out the sentence, I am a B. So B's method overrides the identify method that it gets from A. Now, if I create a B in memory here, let's make a B. Okay, so this is some kind of B. I have some code here, and I write B equals new B. Okay, if I call B.identify, there's no problem. It prints out I am a B just like we would expect it would. This is all the Java stuff the way we've learned it. However, because B is a subclass of A, I can do something a little interesting. I can do this. I can do A equals new B. So here I have an A reference that actually refers to a B object. It's still pointing to this B object in memory, right? So I say if I wanted to, let's be a little more specific here because new B is not going to point to the same one. So if I say AA equals B, clearly they're both referencing the same point in memory, but they're doing it a little differently. So this is an A reference. What's the difference? Well, number one, can only use methods and data in A. So I can call the identify method, for example, and call A.identify because it exists in class A. But if B had a new method, such as void M2, right, and something happens there, whatever, couldn't call A.M2 because the M2 method does not exist. Okay, it doesn't exist in class A. Other thing, when I do call identify, when I do call A.identify, it uses B's version of the method, not A's. Okay, so that's an important distinction. So anytime a subclass has overridden a method, even if you're going through a superclass reference, it's going to use the subclass's version of the method. Okay. So, and all the rest of this examples we have on Blackboard, they cover that same stuff. So, another thing we can check is the instance of modifier. So I'm going to cover that as well in this case. So, instance of operator basically tells us whether a particular object belongs to a particular class. So the basic format is, does this object belong to such and such class? Here I have some stuff in Blackboard, a little instance of test. So, here I've created an A object, AA, and it's a new A object. So of course, that's going to be an instance of A. So this statement, AA, it's a Boolean expression actually, it resolves to true or false. Is AA an instance of A? Of course it is, right? It belongs to class A. It's going to be true. Is AA an instance of B? No, it isn't, because B is a subclass of A, right? So here I have the same thing, class A and B is a subclass of A. Okay, so that second one will be false. Now, interestingly, all the rest of these are going to be true, right? So these two should make sense right off the bat. We'll talk about these. So the first one, if I ask, is BB an instance of A? Well, BB is a B object, but since B is a subclass of A, all B's are actually also all A's. They're both A's and B's. Likewise, if I do this, is BB an instance of B? Well, of course it is, right? It refers to this B object. Another thing we can do, let's talk about A. Okay, so here I have an object A, and it's a new B, right? So I'm using that, what's called polymorphism. I'm creating this subclass as a superclass type. So is A an instance of A? Yes, it is, because it uses the reference type. If I check, is A an instance of B? Strangely, that also resolves to true, because A actually points to a B object in memory. Right? And I couldn't use the A reference here unless B was a subclass. So here, even though A is actually point to a B object, as we saw before, all B's are actually A's. So that works. Likewise, when I create a new B object, B is a new B. Is B instance of A? Yes, because every B object belongs to class A, because class B is a subclass of A. Likewise, is B an instance of B? Well, of course it is, right? We wouldn't expect it to be otherwise. Okay. I guess that's a duplicate there of what we just saw before, but that's okay. Okay, so that's instance of. Now, next stuff, arrays. Just like we saw here, I can use a different array, different reference type to refer to a subclass object. I can do the same thing with arrays. So I could create some array, A equals new A size 100, right? And any of these individual A references, because that's all the objects in this array of type A are, they're references to A objects. The first one, that could reference an A, but the second one, if I wanted, it could reference a B, since B is subclass of A. So, nice thing about this in terms of arrays, if you have a large organization with a lot of complicated applications, a lot of arrays, different class types, it would be a nightmare if every time you wanted to change a class to add in a new subclass into your program, you had to tear out and redo all of your arrays. It'd be awful. This way, any array superclass can hold all of the subclasses forever, and it can use their own versions of the methods in case they operate differently. Okay. Next thing, visibility. I'm going to get rid of all this. So there are 4 visibility levels in Java. It's pretty easy to map them out. So 2 of them actually 3 of them we've already seen. Okay. So the 4 visibility levels are public, protected, default, also known as package private. Let's move that back a bit. There we go. Okay, and the last one, private. Okay. In the basic cases, if a class is public, it can be seen under any circumstances. But we know a private class can only be seen in one case. It can only be seen if not a private class. So suppose, we'll make this, suppose a class has a method or data with the visibility level below. Another class, right, so I'll say a class can access that if it is, okay, same class. Okay, so if something is private, the only thing that can access it is an object of the same class. That basically means that the class is isolated from everything else, or that aspect of it is hidden. For example, we saw that with the array of characters that a string holds. You can't access it from outside the string. You have to go through one of the string methods like length or something to find out how big it is. So that's the case for private. And anything can see stuff that's within its own class, so that's never restricted. Next one, same package. So if you're private, well, unless you're the same class, doesn't matter. Same package doesn't help you. But if you are in default mode, you can always access stuff as long as you are in the same package. That's why when we're doing stuff in Java, we put all of our classes in the same package, and they can generally access each other easily. So the default mode is what's called package private. It has the same visibility if you're in the same package, or what's provided by private. If you're in the same class, then it can access it. In other cases, you can't. So if you're in a different package, you can't. Okay? And of course, and protected and public can also access it if they're in the same package. Next visibility level covers inheritance relationships. So I'll add this is a subclass of the other. Okay? So if the method or data is protected, then any subclass of that class can access it. And we saw this with our graphics, where sometimes we need to access, for example, like the paint component method. That was protected. So when we created special subclasses of a J component, we could still reference that same, paint component method. So that is allowable. Protected, on the other hand, does not cover the case of, none of those cases apply. So protected, you can access it if it's a subclass of the other, or they're in the same package, or they're in the same class. But if you don't have any of those, you can't access it. The public can access it in all cases. So these are the 4 visibility levels. You need to know what they are, when they apply. You'll be asked on an exam. Okay, last thing to cover, because we're almost done. How about that? Last thing to cover is abstract class. Okay, key thing about abstract classes, number 1, you cannot create objects of an abstract class. We've seen that before, like with the graphics class. Second, you can create subclasses of an abstract class. So you can specify in your abstract class all the methods that all the subclasses will have to have. Again, we saw that with graphics, where even though we couldn't create graphics objects, the Java virtual machine behind the scenes had subclasses of graphics that you could send in as graphics objects. Okay, and I suppose that's it. Oh, one last thing. This may be useful on a quiz or an exam one day. If you have an abstract class, you can still have static methods that execute. So even though you can't create an object of an abstract class, you could say, for example, I'll do abstract class C, and I'll actually put some code in here. So void print, I'll just print system.out.println IMAC. Okay? If this method is static, I can access it. As soon as I can reference the class, what doesn't it like there? Oh, I need my last, okay, there we go. I need that method closeout. As long as I include the class, I can access any of the static methods. So if I wanted to, I could do this. I could do C system.out.println C dot, where is it? Print. Isn't that working today? Print stream. Void. Oh, it returns. Oh, yeah, duh. I got to do, just call c.print. Okay, so when I run that, there we go. Okay, and we're done. Quiet, dog.